All right, calculus, we're in the midst of the substitution rule as we're determining integrals. And you should have a solid basis for the basic practice of substitution at this point. Let's go through a few more examples that might be a little bit more complicated for you. In this situation, as you choose u, I want to be clear. Sometimes choosing u, you always look for what's in parentheses or things like that. It's not always the case. But when you choose u, you want to choose u to be something so that when you take the derivative of it, you get something that's close to something else that you have. So notice if I choose u to be 1 minus x squared, I get du is negative 2x dx. Well, getting rid of the negative 2 is no problem at all. So, so that's good. But suppose you chose u to be 3x. Then du would be 3 dx. And while, this is taken care of, we don't have that x squared at all. So that would be the wrong choice. So I can't always tell you what to choose, but we will kind of look at that in this scenario. So here we go. U is equal to, as we said, 1 minus x squared. So du is negative 2x dx. I don't have a negative 2x. I have a 3. So therefore, I'll multiply by 3, and I'll divide by negative 2. So negative 3 halves du is equal to 3x dx. I like to put the negative 3 halves out front, integral du, and I like to cross off what that gets rid of. Gets rid of the 3x dx. What remains? Well, 1 over the square root of u, or u to the 1/2. This is the same thing as negative 3 halves times the integral of u to the negative 1 over 2 du. The antiderivative of u to the negative 1/2 is u to the 1/2 divided by 1/2 or multiplied by 2. I got multiplied by negative 3 halves plus c. Notice that the 2's will cancel, and I get negative 3 roots of 1 minus x squared plus c. That is the indefinite integral. Very algebraic in nature. A lot of people actually enjoy looking through these antiderivatives. As I said, they're very, very algebraic. Here I'm going to choose u to be x squared plus x minus 1. So therefore, du is 2x plus 1 dx. I don't have a 2x plus 1, but I have a 4x plus 2. Those are very similar. If I just multiply it by 2, I get 2 du is equal to 4x plus 1 dx, or 4x plus 2 dx. Now, notice that if this would have been slightly different, instead of 4x plus 2, if it would have been 4x plus 3, it wouldn't have worked out. So we could change anything with an integral by just, a simple number, and it throws us off big time. So, so this is a very nice integral that sets up for us in a nice way. So I do the 2 and the du. That gets rid of the 4x plus 2 and the dx. What remains? 1 over u cubed, or u to the negative 3. The antiderivative of u to the negative 3 is u to the negative 2 divided by negative 2. Notice that those 2's will cancel, and I get negative 1 over u squared, or x squared plus x minus 1 quantity squared plus a constant. This is your integral. Number 7 is a classic problem, and a lot of times people choose u to be e to the x. Well, then du is e to the x dx. Doesn't really take care of that 1 there. Like if you actually went through and now did your substitution, you'd have the integral of, let's see, so that would be gone. I would replace that with du, and then I would have 1 over u plus 1. And that that doesn't really work because we don't know that antiderivative. So let's try a different choice. Instead of u being e to the x, let's let u be e to the x plus 1. The derivative of e to the x plus 1 is e to the x dx. Well, now look at our option here. Integral du, that gets rid of e to the x dx. And then as you can see, u is right here. So I have 1 over u. I wonder if you remember what the antiderivative of 1 over u is. Remember, u to the negative 1, if you increase it by 1, you get 0 over 0. We don't really know what that is. There's something special that you take the derivative of to get 1 over u, and that will be natural log. Natural log of e to the x plus 1 plus constant. The next one, you really have a choice here. You could have u is equal to cosine of x, and then du would be equal to negative sine of x dx. And as you can see, you've got this sine thing going on over there. Or you could choose u to be sine of x. And the derivative is cosine of x dx. As you can see, this is a better choice. Because as you set it up, we have the integral of 4 du. That gets rid of, for us, the cosine of x dx. And the 4, we've used the 4 up. And then we have that thing squared, so 4u squared. Antiderivative of 4u squared is 4u cubed over 3. And then we're going to go ahead and substitute u back in. So we got 4 sine cubed of x over 3 plus a constant. That's the antiderivative. Okay, good work. You now know the basics of substitution. This will make up our third video, which we'll do later on. I do want to turn to your homework really quick to make sure that we are of a clear understanding of what you're going to be working through at this point so that you don't take too much time in the wrong direction. But as you look at this, there's a lot of problems practice. That's because they're really good problems. We need the practice. Integrals can come up in all sorts of different shapes and sizes. You can definitely complete the first 2 pages. As you look at the third page, you're now definitely capable of getting through this third page. As you get to the fourth page, there are some more challenging ones here, especially as you get to problems 31 and 32. At this point, you would not be able to do problems 31 and 32. Maybe save this last page, especially 31 and 32, for after we get through the third video. We'll see you guys later. Short video for you.